Hey there, grade nines. So today's lesson, we're going to be talking about determining the surface area of objects made from right rectangular prisms. So some of you might not quite remember what a right rectangular prism is, which is totally fine. So I actually have an example for you on the board. So as you can see, what this is actually a building. This is something that was built in Amsterdam, in the Netherlands, and they're actually cube houses. Right? Here's another picture of them, and they're actually pretty neat architecturally speaking, because they're just full squares on top. So it's kind of to try to have kind of a real life application. So say this is built and you want to put the siding on it. How are you going to determine what the surface area is? So right rectangular prisms, just as a reminder for all of you, is a prism similar to these linking cubes where you've got right angles and they can make rectangular shapes or square shapes. So like some type of like a cereal box would be an example of a right rectangular prism. So what we're going to do is we're actually going to do a little chart. So if we have the number of cubes, and then we go the surface area in units squared. All right. So if we have just one cube, all right. So we're looking at just the one cube. What will the surface area of this be? And I'm going to assume that every side I'm just going to call one square unit. All right, so when I look at it, I've got 1, 2, 3, 4, 5, and 6 square units. Okay, so I counted all of them up. I'm up to 6 square units. I'll try to write it a little bit bigger so that you can see it better on the screen. Next, what if I have 2? Okay, so now, when I'm looking at it, I've got different views. So I've got the front view, which is the one that you can see. I have the back view, which is the one that I see, so when I flip it around. Then you've got the top view, the bottom view, and then both side views. So when you're looking at red or you're looking at pink, is going to determine which side view you're talking about. So what we can say is we know that our sides, our outsides, so our red and our pink are going to be 1 each. Okay, so I'm up to 2. And then I've got 2, 4, closest to me is 6, and then underneath is 8, plus 2 is 10. Okay, so I have 10 square units. Now what if I add a third cube? Okay, let's add a third cube. Let's go this way. All right, so I've got it looking a little bit different now. Okay, now it's making almost like a little L shape. When I look at my front face, I can determine how many units there are. So I can go 1, 2, 3. When I look at my back face, it's going to be the same, 4, 5, 6. Okay. Now, if I look at my side view here, 7, 8. My other side view, 9, 10. Okay. My top view, 11, 12, and then 13, 14 for my bottom view. So my whole surface area for this one is 14. Oops. Now let's see what happens if I add one more. Okay, so let's put it like this. So we've got kind of a Tetris piece going on here. All right. So I'm going to look at all of my views again. So when I look at my front view, I've got 1, 2, 3, 4. When I look at my back view, 5, 6, 7, 8. Okay. If I look at my top view, 8, I'm at 9, 10, 11. My bottom view, 12, 13, 14. Then I'm going to look at my two sides. Okay, 14, 15, 16, 17, 18. And that's going to be all of my sides. That's my surface area. Some of you might already be recognizing a pattern, all right, which is fine, and that's awesome. So let's actually try to think about what happened. If you're looking at the pattern, we can see that as we add a cube, the surface area goes up by 4 every single time. Okay, so why is that happening? Well, let's think about it. I've got my surface area here that I have 18. what's happening? I'm adding one that has 6, okay, but one of the faces is going to get covered up. So, but I'm only adding 4. How is that going to work? Well, when I place it in, I'm actually eliminating one of my other faces as well. All right, so when I'm adding a cube, I'm technically only adding 4, because when I look at my front view, this one was technically already counted. So what am I adding? I'm adding 1, 2, 3, 4, okay, from all of the other views. So if some of you may have guessed that your surface area is going to be 22, and we'll count. So when I look at my front view, I've got 1, 2, 3, 4. Okay, back view, 5, 6, 7, 8. Okay, I'm going to go top view, 9, 10, 11, 12. Okay, bottom, 13, 14, 15, 16. I'm going to go my side, 17, 18, 19. And then my other side, 20, 21, 22. So that worked out perfect. So I've got 22. So as we're going, you could probably predict. Okay, so we could make some type of an expression for as we're adding on cubes, what the actual surface area is going to be. So what I've got for the next little bit is we're going to have just some. I'm going to give you a bunch to look at. Pause the video, and then you can determine, and I'll slowly rotate it so you can count each of the sides. All right, so you're going to determine the surface area of each of them. So there's 6. So hopefully it doesn't go too long. So we'll write it down like this. Okay. So we've got our cube number 1, and it's going to have 3 cubes. Cube number 2 is going to have 4. Then we're going to have 5, then we're going to have 6, then we're going to have 7, and then we're going to have 8. Okay? So that's how many cubes are going to be in each of them. So our first one looks like this. All right, so we've got that L shape again, which we talked about before. So pause the video if you want. I'm going to slowly kind of rotate through. There's the side view, back view, other side, top, and bottom. And then we're back to the front. So if you have it on pause, you can actually calculate. So we've got 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 on this one. Okay, so just to go over that one more time. 1, 2, 3. If I go to the back, 4, 5, 6. Top, 7, 8. Bottom, 9, 10. Now I'm going to do the sides. 11, 12, 13, 14. All right, your next has 4, and it looks like this. Okay, so I'm going to slowly kind of rotate through, pause the video if you want, and then you can kind of calculate what the surface area is going to be. So there's my back view, okay, top view, bottom, side, and side. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I got 18. All right, next one looks like this. Okay, so let's try to determine what the surface area is. So we've got our front, back, top, bottom, side, and side. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, the next one, we have another one with 5. Okay, so, so I messed that up. So this one actually has 5 in it, and then we have 6, and then we have 6 again. No, 7. All right. So this one looks like this. So a little bit different than the last one. So again, let's see if it changes at all. So we have our front, back, top, bottom, side, and side. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh, top, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Huh. Well, what happened? How come it's less? Well, because we have this piece here that is touching in multiple spots. So it's actually canceling out a couple more. Okay? All right, this one might be a little bit trickier. It looks like this. So you can kind of see from the three-dimensional. So we've got our front view, back, top, bottom, side, and side. So when I actually go and calculate, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this one has 22. And that one actually only has 5 pieces. So we're back to 5 pieces. Last one. So this one has 6 pieces. So some of you might be able to guess already exactly what the surface area is. So when we look at it, it looks like this. So you can kind of see it from a three-dimensional shape. So we have our front, back, top, bottom, side, and side. So when I go and calculate it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, top, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, side, 21, 22, 23, 24, 25, 26. Okay. So what's the difference? Okay, what's the difference when we're looking at specifically these 3? Okay, well, even any of these 2. Okay, what we have is, as the difference between these is we're basically moving this piece down to here to get this shape. Okay, what that does is that eliminates 1, 2, and then 3, 4 possible areas. All right, so if I take this piece out and I'm putting it in here, right? So here we had, it was eliminating 2. It was eliminating this one, and it was eliminating this one when I put it together. But when I place it in here, it's eliminating 4 spots, 4 possible spots. So this one, this one, this one, and this one are all gone. So what am I technically adding? I'm not adding 4 like I used to. I'm actually just adding 2. All right, because this one here was already there from the brown. Okay, so that's not changing. That's not adding any surface area. Okay, this one here was already there from the blue. Okay, so the only ones that are actually being added are here. Sorry, when I'm looking at the front and when I'm looking at the back. So those are the only 2 that are being added. So if I add another one here, then it's only going to be adding the front and the back because my surface area from the top is already there. My surface area from the side is already there. All right. So that's kind of the difference between each of these. I'm going to post some questions for you. They're going to be, I'll copy and paste some questions from the textbook for you all to practice. And then you can just submit your questions in a Google Doc. And if you have any questions, bring those to the Google Hangouts. Sorry, this video is a little bit longer than usual. I'll try to make them as short as possible, but it was a lot of demonstrating to try to help you all understand. All right, good luck.